Swayam Prabha. Digital India. Educated India.
Now, in this scenario, the next thing that is of interest is to find the neutral axis of the cross section. Okay. When the beam was bending along one direction, okay, the neutral axis was a straight line parallel to the or perpendicular to the line of the action of the load. Okay. Now, when the bending is about two directions, neutral axis will be an inclined neutral axis inclined to both the directions of the load. So, we want to find what is the orientation of the neutral axis of neutral axis. Okay. We saw that neutral axis is the axis about which the stress is 0. Okay. We saw the definition that neutral axis is the line in the cross section along which normal axial normal stress is 0. Okay. So, you know that sigma xx has to be 0 along the neutral axis location. Okay. When the beam was bending along only one direction, when you add sigma xx given by y minus y naught mz by izz, you know if this is 0, this implies y equal to y naught, and that was the definition of the neutral axis. Now, when sigma xx is given by a complicated equation or is given by this case special case where given by this special case where I yz is 0 and there is moment along both the directions my and mz moment, then what is the neutral axis? Neutral axis would be minus y naught, I left a negative sign here, y minus y naught mz by I z plus z minus z naught m y by I y has to be equal to 0. Okay. This implies z minus z naught by y minus y naught must be equal to I y by I z into mz by my. Okay. Now, what is this y equal to mx plus c, where c is the origin. Now, this is the slope of the line. Okay. This is tan beta, that is if I have cross section with y and z oriented like this. Okay. This equation in here represents the equation of a line whose slope is beta. Equation represents equation of this line, okay, whose slope is beta measured from y like this, okay, whose slope is beta measured from y like that, given by that equation in here. So, basically you have rearranging this equation, z is equal to y minus y naught tan beta plus z naught, where this position is y naught z naught. Okay. That is y naught z naught. If you are taking it as an origin, y naught and z naught are 0 and this represents the tan beta. Okay. So, the stress sigma xx is 0 about this line. the stress sigma xx is 0. So, this is the neutral axis of the cross section. Okay. Unlike the shear center, unlike the center of the cross section, the neutral axis depends upon the loading. Okay. It depends upon the bending moment my and mz that comes in the cross section, then orientation of the neutral axis will change with the loading. Okay. This is the important point to be noted. Neutral axis is not a geometric property, it is a load dependent property. Okay. So, basically that represents the equation of that line, and that is the neutral axis, that is the axis about which the axial stresses are 0. Okay. Now, let us consider a general case. In the general case, what happens? The general case I will get tan beta as again z minus z naught by y minus y naught, which will be tan beta. In the general case would be, by general case I mean this expression. I am going to now equate this to 0 and write z minus z naught by y minus y naught as this divided by this expression in here. Okay. So, that will be Iyy mz plus Iyz my divided by Iyz mz plus Izz my. Okay. So, this is the general orientation of the neutral axis. This expression gives expression for orientation of the neutral axis. Okay. So, this gives the orientation of the neutral axis. Okay. So, now what we have seen is, we have seen what happens when there is loading along the principal axis, both the principal axis of the cross section, we got the expression for stress, and we generalize to the case where the loading was applied in one direction, not necessarily along the principal axis direction, and we got an expression for that, and then we found the expression for the neutral axis. Now, in a practical problem, there are two ways of solving a problem. Okay. You can choose any axis for a given orientation of the load. Okay. And then you can say that find all the moment of inertia, cross moment of inertia and Iyy, Izz moment of inertias, and then substitute in the general expression and solve for a problem in a general manner. The second approach is you find the principal axis of the cross section, resolve the loads or moments along the principal axis of the cross section, and use only the principal axis, the first equation that we derived in today's lecture, to solve the problem. Okay. In the next lecture, what we will do is we will take a specific example of an angle section and solve it when it is loaded about one of the legs and when it is loaded about one of the principal directions, to find the displacement as well as the moment and stress expressions. Okay. Thank you.